Hello everyone. Now we have to discuss the last type of connection, that is analysis of delta connection. Delta connected supply system, delta connected load system. So this is the example. A delta connected load is having 10 at an angle minus 67.5 ohms impedance per phase. If the delta connected supply has a phase voltage of 30 at an angle 30 volts. Now we have to get the all related quantities. Okay. First we have to get the connection diagram, right? Supply is what? Delta supply. So this is one winding, this is another winding, this is another winding. Clear? Now the load is also delta connected load. Okay, let us take, this is one phase, this is another phase, this is one phase. Okay, so we have a load like this. Okay, that's it. So what is the impedance for this? Given that 10 at an angle minus 67.5 ohms, 10 at an angle minus 67.5 ohms, 10 at an angle minus 67.5 ohms. That's it. Now we have to connect this. This is Y, like that. This is phase, right? R, Y, P, R, Y, P. That's it. What is the voltage if the delta connected supply has a phase voltage of 30 at an angle 30? Given that the supply voltage, that too, yeah, phase voltage is nothing but 30 at an angle 30. If it is 30 at an angle 30, this is what? 30 at an angle 30 minus 120 minus 90. This is what? 30 at an angle minus 210. That's it. Okay. This is the connection diagram. We know that. So total is delta. Therefore, VL is equals to V phase and IL is equals to root 3 I phase. That's it. The analysis of star delta is easy compared to star delta star, right? Next we have to get the nothing but phase. First we have to write phase voltages are line voltages because both are same, right? So from this, phase voltage is what? VRY, right? Which is equals to, given that 30 at an angle 30 degrees, like that VYB, which is equals to 30 at an angle minus 90 degrees, like that VBR, which is equals to what? 30 at an angle minus 210 volts. Completed, which is nothing but phase voltage as well as line voltage. Given that impedance per phase, which is equals to what? 10 at an angle minus 67.5 ohms, right? Therefore we have to get phase currents now. Phase currents. In case of delta connection, phase current is nothing but V phase by I phase, right? Therefore IRY, first we have to get between IRY, is IRY, right? Which is equals to V phase is what? That is VRY by 10 at an angle, what is the value? Minus 67.5, right? Given like that, which is equals to, which is what? At an angle 0, sorry, 30 degrees. See, provided 30 degrees, right? which is equals to, what is the value of VRY? That is 30 by 10, which is equals to 3. 3 at an angle, we have 97.5 amperes. Like that, I by B, which is equals to what? 3 at an angle minus 22.5, right? Like that, IBR, which is equals to 3 at an angle minus 142.5 amperes. That's it. Okay, this is what VR by V by B at an angle minus 90 minus 67.5, that is minus 90 plus 67.5, we have to get minus 22.5. So these are the phase currents. Next, line currents. Line currents, right? In case of delta connection, line currents are what? We know that before that, line current lags phase current by 30 degrees. Therefore, line current is what? IR, right? Which is equals to root 3 times of IR by at an angle plus 30, which is equals to root 3 into IR by is what? We have finally 5.2 plus 30, sorry, minus 30. Here line current lags, right? This is not plus, this is minus. So IRY is what? 97.5 minus 30, which is what? 67.5 amperes. Like that, IY is what? 5.2 minus 22.5 minus 30 minus 52.5, right? Like that, IB, which is equals to what? 5.2 at an angle minus 172.5 minus 172.5. That's it. We have completed phase voltage, line voltage, like that phase current, line currents. Then Phasor diagram. Simple analysis is what? Just we have to get the all quantities, whether it is line voltage or phase voltage or line current or phase current. That's it. Phasor diagram. Okay. First we have to draw phase quantity, that is VRY. This is VYB. This is what? VBR. Completed. Next, what about phase current, that is IRY? What is the angle? That is impedance is what? 67.5, right? Current leads, impedance is negative angle, therefore current leads. I have to write that point. I phase, impedance is negative, right? It's V phase by 5. 5 is what? 57.5. Therefore 67, right? This is 5. This is what? IRY, angle between phase current and phase voltage. Then we have to get line current. What is the angle? See, the line current is what? 67, sorry, it is 97.5. Yeah, 67.5. But here the phase voltage is what? It is starting from plus 30. So it is 67.5, that is 37.5 minus 30, that is 37.5. So this is what? 37. This is IR. This is what? 37.5 degrees. See, to get clear analysis, this is at 30 degrees. This is what? 60. So 37.5 plus 30. This is at 67.5. This is what? 97.5, right? To get clear, given phi is 67.5. Sorry, not given, obtained. Of course it is given, right, because he provided the impedance, no problem. That is, power factor is leading power factor, means what? I phase leads P phase by phi. Phi is equals to what? 67.5, right? We know that if phi is more than 30 for leading load, the angle between V line and I line is what? Phi minus 30, which is equals to what? Phi is what? 67.5 minus 30, which is equals to what? 37.5, like this, right? That is the angle between what? VRY and IR, which is equals to 37.5. Satisfied? That's it. This is what? 67.5, which is equals to 67.5. This is starting from 30. That is, if we add 30 degrees to this, 67.5 between this is 97.5. That's it. This is the phasor diagram for this delta connected delta load. That's it.